So in this video, you can see our solution for example number 1. Example number 1 is taken from number 19, page 340 of Christian. I recommend that you read the problem first before you continue on with this particular video. Try to understand what's going on, and on a piece of paper, try to summarize for yourself the important information, like what I've done here, and the information being asked of us, like the percent of the potassium cyanide present in our sample. So when we're trying to be able to compute the percent composition of our solutions, like what we have in here, we always try to start off with this particular pair of data. A volume and a concentration together. These two, when multiplied together, 34.95 ml multiplied by the concentration should give us the concentration, or rather the number of moles of the silver ion. So that's very easy data to obtain just by multiplying these two. So we're always on the lookout for these two data placed together. Now, as it turns out, we were already given equations in here, so we're quite lucky in this particular problem. If you can see in here, 1 mole of our silver ion is always going to react with 2 moles of the cyanide ion. That's why, to continue on with the stoichiometry, we have here the following. We have 2 millimoles of cyanide for every 1 millimole of silver ion. And we try to continue on with this. Continue on with the stoichiometry so that by the very end of this stoichiometric manipulation, we're able to arrive at what it is we're being asked for in our problem. So in our problem, we're being asked about the KCN. So always our end goal in mind is to be able to know just how much KCN there is. And from the formula of KCN, we have 1 millimole of KCN containing always 1 millimole of CN. So plugging in the necessary values to your calculator, we're able to compute that there is 7.16 millimoles of KCN in our sample. So for this one, we can continue on with the computation. We want to be able to convert the millimoles of KCN into mass, since our sample in here is expressed in mass. So we want to be able to do mass of KCN divided by mass of sample to get the percent of KCN. So look it up on our periodic table. The molar mass of our KCN is found to be 65.116 milligrams of KCN for every 1 millimole. And so once again, plugging it into our calculator, we're able to compute the number of milligrams of our potassium cyanide. So once this particular value is obtained, we now simply have to compute what's being asked of us. So when we're being asked about the percent composition, we just simply have the percent of the analyte is equal to the mass that we've computed over here divided by how much sample we were originally given. So for us, we now have 466.54 milligrams of KCN divided by 472.3 milligrams of the sample. What I like to do is I just try to convert mentally already the grams into milligrams. If you are having difficulty with that one, you just simply have to multiply this, the grams, by 1,000. That way, from this gram of sample, you're able to obtain the milligram of sample. Now divide the 2 times 100% gives us our answer of 98.78%.